Hello friends, welcome to Risingpearl.com. Today we are talking about series 8 where we are learning a lot about arithmetic progressions. Friends, I hope you are following us along at Risingpearl.com. Today is webisode number 11 and today we are going to take a look at how do we solve questions where we need to calculate the sum of n number of terms of a given arithmetic progression. This is part 7 and part 7 means there are 6 parts earlier 6 webisodes where we have taken a look at solving all kinds of questions on arithmetic progression. So I hope that you are really following us along at risingpearl.com. So please make sure that if you have not got a chance to take a look at the previous webisodes that you do take a moment and take a look at them to understand and appreciate all kinds of questions that you may see in the test and in your exams, and how, more importantly, how do we solve those types of questions. So let's begin by taking a look at how do we solve questions where we may need to find out the sum of first n number of terms. So we are going to begin by this question, which is that find 1 plus 2 plus 3 plus 4 plus ... plus 98 plus 99 plus 100, which essentially means find the sum of the first 100 whole numbers, right? So we have just seen that the formula, well, first thing is that you must immediately realize that you start with one term, obviously, and each subsequent term is, you get each subsequent term by adding 1 to the previous term. So this is an arithmetic progression. So this is an AP, and the first term is equal to A, as we can see here, and the common difference is you take any term and you subtract the previous term from it. So 3 minus 2 is equal to 1. So the first term we know, which is A, and we know the common difference is 1. So now we have just seen the formula to calculate sum of first n number of terms is n by 2 times 2a plus n minus 1 times d. And so what we can do, we can simply plug the values in and find out the sum. So let's do that. Why don't we do it? And what is n? N is the number of terms. We start with 1 and we go all the way to 100. So how many terms are there? 100. So we have n is equal to 100. So let's just put the values in here. So n is 100 times 2. 2a, a is 1, right? 2a, a is 1. Plus 100 minus 1, which is n minus 1 times 1, because d is 1. So we have this, and let's see this value. So 2 5s are 10, 50, so we will have 50 times, what do we have here? We have 2 plus, so 2 1s are 2, plus 100 minus 1 is 99. We have 99. Or this will be 50 times 101, right? 101. So if you do 5 multiplied by 101, it will be 5, 0, 5, and then 1, 0. So the sum of 1 plus 2 plus 3 plus 4 all the way till 100 is 5050. So I want you to just take a moment and pause the video and see how powerful arithmetic progressions are, and how using this simple formula that we can actually find out the sum of all these numbers, right? And remember, I said there are two ways to solve this. The other way is that we also saw this formula can be written as really n by 2 times a, or the first term, and the nth term, the last term, right? Because we looked at, if we just split it, we write the 2a as, if we write this as a plus a, right? Then this a plus n minus 1 times d is the nth term, right? A plus n minus 1 times d is the nth term, and this is the first term. So it's first term plus nth term. So quite simply, looking at this series, what you can do, you can say, well, n is 100, there are 100 terms. let's take a look at the first term, which is 1, and let's take a look at the nth term, which is 100, right? So we simply put this, and now you have same thing. This is 50. So you have 50 times 101, which is 50 times 101. What you have here, it's the same thing here, and the answer again is 5050. So now you can really imagine how powerful this is. You can even brag to your friends who have no idea about arithmetic progression just yet, and you can say, wow, look, I mean, just simply, and this is any arithmetic progression series, right? Just simply by taking the number of the terms in the series by 2 times the first term plus last term, you get the sum of all these terms in the series. This is really fascinating. Let's take a look at more questions. So now, how about if we have to find the sum of the following AP, 1 by 15, 1 by 12, 1 by 10, and we have to find out the sum for first 11 terms. So how do we do this? So the first 11 terms, so first of all we have to find out clearly our first term is this 1 by 15. Now to find the difference, we need to find out the common difference. So we take the second term, we take A2 minus A1, right? We could have as well taken A3 minus A2, it would have been the same thing. So 1 by 12 minus 1 by 15. So if we do this, so this will be, let's see, so 12 is 3 times 4, and 15, we have to do the LCM, right? It's 3 times 5. So essentially we can say it is 3 times 4 times 5. So which will be 3 times 5 is 15 times 4 is 60. 60 will be LCM. 12 5s are, so this we get 5 here, minus 15 4s are, so this will be 4. So then 1 by 60. So our common difference is 1 by 60, right? So now let's find out. So the sum of first 11 terms will be given by n by 2 times twice a plus n minus 1 times d. So let's just put the values in here. So n is 11 because we are trying to find out the 11 terms. 11 by 2 times 2 times a. A is 1 by 15. 1 by 15 plus n minus 1, n is 11 times this, times common difference is 1 by 60. So all you have to do, you have to just solve this, right? And then you will get the answer. So it will be 11 by 2 times, this will be 2 by 15, 2 by 15 plus 11 minus 1 is 10, 10 by 6 is 1 by 10 by 60 is 1 by 6. So if you can just solve them, you will get the answer. I know that all of you are much smarter and you can easily find out the value. So once you find out the value, that will be the sum of first 11 terms of this series. Let's take a look at some more questions. I want to make sure that I can cover as many types of questions as I can. So here, interestingly, we have given arithmetic progression. So we start with minus 5, plus minus 8, plus minus 11, and plus the last term is given. So here, interestingly, the number of terms is not given. So we don't know number of terms. But what is that which is given? So the first term is minus 5. We can see that, right? And because we have been given consecutive terms, we can find out the common difference. So let's say we take minus 5. We take the second term. This is our first term. This is our second term. This is our third term, right? So we can take any two consecutive terms. So let's say we do this time. Let's say we do A3 minus A2. So if we do that, A3 is minus 11. Minus, what is A2 minus 8? So minus 11 plus 8 will be minus 3. So we know A, the first term, minus 5, and we know the common difference is minus 3. Don't forget the minus term, right? So what we have, let's write it here. So we have a equals minus 5, and our common difference is minus 3. Now, in order for us to find out the sum of these terms, we need to find out n. So let's say there are total n number of terms here in this series. Then the nth value, there are total n number of terms, so the last term is the nth term, that is a plus n minus 1 times d, correct? Or now a is minus 5 plus n minus 1 times d is minus 3. So the nth term, if there are total n number of terms, so nth term is the last term, right? Because there are total n number of terms. That's what we are assuming. Let's say there are total n number of terms. Then nth term is an. But that value is given as minus 230. So we are going to say this is minus 230, right? So we have like a negative 5. So you know what, let's do one thing. Let's just simply solve this and find out what we get. So on this side we have minus 5. If we were to open this up, right, if we were to multiply this, so let's say we will have minus 5 minus 3n. This will be minus 3n, minus 3 times n, and then we will have plus 3, because minus 3 times minus 1 is plus 3. This is equal to minus 230. Or if we solve this, let's take the minus 3n. Let's take the minus 3n to the other side of the equality, so it will become plus, and this minus 230 we will bring it on this side of the equality sign. So minus 3n, so plus 230, so this side will be 230, and minus 5 plus 3 is minus 2, right? Minus 5 plus 3 is minus 2 will be equal to 3n, or 3n is equal to, this will be 228, right? Or from here we can find out that n will be equal to 228 divided by 3. So 3 7s are 21, 1 8, 6, 3 6 18. That means in this series what we have just found out, there are 76 terms. So now we know n is equal to 76. So at this point, friends, we can simply say the sum will be equal to, we can do it again in two ways. We can simply say it will be n by 2 times, we can use the formula 2a plus n minus 1 times d and find out the value, or we can say it is n by 2 times the first term minus 5 plus the last term minus 230 and find out the value, right? It's important that even if you want to use this formula, that is n by 2 times first term plus last term, we still need to know how many terms are there. So we have to calculate the value of n to find out number of terms which are there. So n is 76. So simply if we were to now just put the values here, 76 by 2 times, so this will be minus 235. So whatever this comes out to, so this will be 38, right? So answer will be minus 235 times 38. So whatever the value is, that is the sum of this series, minus 5 plus minus 8 plus minus 11 all the way till minus 230. Let's see if you want to take a look at one more question. So in an AP, it is given that common difference is 5. Okay, so D is given. And S9, well, we have not seen this yet. So let's take a look and understand what is S9. We have to find out the first term and we have to find out the 9th term. So again, friends, at risingpearl.com, it is my goal to give you exposure to different types of questions that you may see in your tests and exams. So I'm walking you through different flavors of questions. So now let's take a look at what is S9. Recall how we say the first term is A1, the second term is A2, the third term is A3, so on and so forth, right? The nth term is N. So this is the subscript. How we represent the first term, the second term, the third term, so on and so forth, and this is the nth term. Similarly, Sn will be the sum of first term plus second term plus third term, so on and so forth, till plus an, nth term. So if we say S3, what it means is sum of first three terms. This is what it means. So it means A1 plus A2 plus A3, and we stop at this. Because 3 means sum of first three terms, first term, second term, third term, and we stop. So if we have S9, what it means is it means A1 plus A2 plus A3 all the way till we get to A9. S9 means sum of first 9 terms. That is what this means. So now let's go back to the question and see what is given. Common difference is 5. So now we need to find out A, and we need to find out then A9. So if we find out A and we know the common difference, we can easily find out the ninth term, right? Because we know that nth term is simply A plus n minus 1 times D. So if we know A and n is 9 for ninth term and D we know, then we can find out the value of the nth term or the value of the ninth term. So we have to find out A. So now let's take a look and see what is given. So when S9 is given, what is the formula for S9? S9 should be n by 2. Remember, n equals 9. So n by 2 times twice A plus n minus 1 times D. So what we have done is we have put n equal to 9, because S9 means sum of 9 terms. So n equal to 9. So n by 2, 9 by 2 times 2A, the first term is A, plus n minus 1, n is 9, times D, right? So in other words, let's actually do this. So we have 9 by 2 times twice A plus 9 minus 1 is 8 times, what is the D? D is given as 5. And it is also given that this value S9, that is sum of first 9 terms, is 75. So this value is 75. That is what is given to us. So let's see from here. So let's go here. So in other words, let's actually take the 2 on the other side and we divide the side by 9. So we have 2A, which is 2A plus 40. 2A plus 8 times 5 is 40, equal to 75 times 2 divided by 9, right? When you take the 9 and the 2 on the other side of the equality, so the 2 is multiplied and 9 is divided. Or in other words, let's see, so we can say this is 3 3s are and 3 25s are. So this will be 25 times 2 is 50 by 3, right? So we have 25 2s are 50 by 3. Or in other words, if we were to calculate this, so 2A will be equal to plus 40 will become minus 40 there. So it will be 50 by 3 minus 40. So 3 will be the LCM. 50 minus, denominator is 1. So 40 3s are 120. Or in other words, what we have here is A will be equal to, if we solve this, so this will be minus 70, right? So this will be minus 70 by 3, and 2A is equal to minus 70 by 3. So minus minus 120 plus 50 is minus 70 by 3, which is equal to twice a. So a equals to this 2 will go to the denominator here, times 2 on the denominator, and 235, right? So 35 is a 70, so it will be minus 35 by 3. So the first term is this. So now we know that a is minus 35 by 3, right? You may want to check your calculation, see that if we have not made any mistake. But if this is a, now using this formula, so we have found the value of a. So the nth term, we will simply put now, so if it is minus 35 by 3, let's do one thing. Let's see if we can give ourselves a little bit more space. Minus 35 by 3. So we have a equal to minus 35 by 3, right? And d is given as 5, and a9 means ninth term, so n should be 9. So a9 will be equal to a plus n minus 1 times d, or if you just put the value, a is minus 35 by 3, right, plus n is 9 minus 1 times d is 5. So if you were to solve this, simply minus 35 by 3 plus 9 minus 1 is 8, 8 times 5 is 40. So if you solve it, whatever the value you get, that will be the ninth term of this particular series.